When it rains, who out there has seen the bright rainbow sheen created by toxic pollutants on your streets and in your local parking lots? Did you shake your head as you watched the rainbow meander its way like flowing lava towards a storm drain with a fish painted on it? But did you know that there's actually technology out there that's been around for over 100 years that will address this issue? It's called pervious concrete, and it forms a rigid pavement surface full of voids which allows the passage of storm water directly through the pavement. By allowing rainfall to pass through the pavement into the soils below, the entire pavement area is used as a detention system, which could reduce or eliminate the need for separate drainage structures. Pervious concrete's environmental benefits are vast, and with the steady continuation of land development, its contribution to sustainable development will prove essential to the generations of the future. On streets and parking lots, pollution from vehicles and other sources in the forms of hydrocarbons such as oil and grease and heavy metals, which are found in brake linings and sediment, accumulate on pavement surfaces and are a major source of pollution for most stormwater management systems. According to the EPA, about 90% of the surface pollutants are carried off by the first half inch to 1 inch of rainfall, and this is known as the first flush. In conventional impervious parking lots, the polluted rainfall flows into storm drains and eventually into streams, lakes, and rivers. A pervious concrete system treats these pollutants and allows clean water to enter the native soils below. Pervious concrete's base rock and subgrade soils filters and treats the rainfall in the same manner as the site naturally did before the pavement was constructed. Additionally, rainfall absorption is spread over the entire parking area instead of concentrating the water and pollutants in one spot, such as in the case with the conventional detention pond. The United States Environmental Protection Agency has rules in place concerning stormwater management under the Clean Water Act. The EPA Stormwater Phase 2 final rule requires that municipalities whose population exceeds 50,000 is required to manage their own stormwater discharge by using best management practices, or BMPs. The use of pervious concrete systems is recognized by the EPA as a best management practice for stormwater management and is quickly becoming a material of choice for construction of parking area pavements with compliance with this ruling. A pervious concrete system can be designed to address the EPA quality and quantity requirements by reducing or eliminating the amount of runoff and the level of pollution in the stormwater runoff from a property. Sustainable development allows construction for current needs with consideration and conservation of resources for future generations. Pervious concrete allows responsible and necessary development to take place while protecting the environment. Case in point would be the recharging of the groundwater tables and aquifers. An aquifer is a water-bearing stratum of permeable rock, sand, or gravel that lies at varying depths. Many areas use the aquifers for their drinking water and pump the water to local communities and maybe even yours. Rainfall, as it soaks into the ground replenishes these aquifers where they exist, and many areas of the U.S. are dealing with water shortages and diminishing groundwater supplies. Yet by increasing the area of impervious surfaces, abundance of precipitation is allowed to run into storm sewer system, bypassing the process of natural recharging of the groundwater tables. Pervious concrete systems allow rainfall to percolate back into the soil, thereby replenishing the aquifers and ground tables naturally. Impervious pavements keep essential water and air from tree roots. In fact, many communities have adopted regulations that prohibit the construction of impervious pavements within the drip line of trees. This can prove difficult in places where trees are within or near roads, parking areas, or other hard surfaces. An increasingly practical, sustainable development solution is to use pervious concrete for these hard surfaces, because this allows rainwater and air to pass freely through the pavement to sustain the tree roots. Care must be taken, however, to protect the roots during the concrete construction. Pervious concrete is considered a low-impact development process, and it is a leader in energy and environmental design because research shows it addresses the heat island effect. Pervious concrete absorbs and stores less heat than conventional impervious pavements. This is because the lighter color of some pervious concrete pavements' ability to reflect radiant thermal heat, while its open void structure permits Earth's cooler temperatures from below, along with water evaporation to cool the pavement. The research at Berkeley National Laboratory at Berkeley, California, has also shown that the use of light and heat reflective materials for roofing and pavements, along with planned planting of trees, could lower the average summer afternoon temperature in some cities by as much as 5 degrees. This would cut the need for air conditioning by an estimated 18%, and since all energy from air conditioning to lights uses fuel, pervious concrete can help reduce global climate change by reducing energy consumption and related greenhouse gas emissions. These factors allow pervious concrete pavement to approach natural ground cover characteristics in heat absorption and storage capacity. However, there are some disadvantages and misconceptions surrounding pervious concrete systems. One disadvantage is cost. Some estimates put the cost of pervious concrete paving at 2 to 3 times that of conventional asphalt paving. Traditionally, the off-site environmental impact cost of not reducing on-site stormwater volumes and pollution have been ignored or assigned to other groups such as local government parks, public works, and the environmental and restoration budgets. These increases drive up costs for these groups since their facilities are only designed to handle a certain amount of volume. Another disadvantage of pervious concrete is the maintenance involved. The voids in the pavement can get clogged with dirt, sand, organic material, and gravel, and require maintenance. This is commonly performed by industrial vacuums that suck up the settlement, but if maintenance is not carried out on a regular basis, the surface will act more like impervious surfaces. There are also misconceptions about pervious concrete systems. One example is its limitations with respect to pollutant loads. Pervious concrete is not a cure-all and cannot handle whatever one throws at it. Highly contaminated runoff can be generated by some land uses producing pollutant concentrations that exceed those typically found in stormwater. These hotspots include commercial nurseries, recycling facilities, fueling stations, and hazardous material areas. Since pervious concrete systems are an infiltration practice, it should not be applied to stormwater hotspots due to the potential for groundwater contamination. Another misconception about pervious concrete is that it can be used anywhere traditional concrete is used, and this is not the case. Pervious concrete contains no reinforcement and is therefore unable to be used for heavy-duty road applications such as freeways or for structural purposes such as load-bearing walls. There are advocates for more widespread use of pervious concrete systems where applicable for benefits ranging from pollutant treatment to the recharging of groundwater tables. But there are also opponents of pervious concrete systems which claim it is too expensive compared with paving options and require too much maintenance. Valid arguments are present on both sides. In conclusion, as technology advances and sustainable development becomes less expensive, you will start seeing sustainability influence development decisions by governments and large developers through practices such as pervious concrete. Thank you.